You know, when you look at a massive skyscraper, you just know it didn't happen by accident. It started with a really detailed blueprint. Well, the digital world, it's exactly the same. To handle all the insane amounts of information that power our lives, you need digital architects, and you guessed it, digital blueprints. So let's take a look at what those are all about.
I mean, really think about that for a second. Every single show you watch, every recommendation it spits out, every user profile it saves, that is a staggering amount of data, and it's all connected. So how does it all stay organized and just work?
And for databases, that blueprint has a name. It's called an entity relationship diagram, or as we call it, an ERD. This is the master plan. It's what makes sure all that data is stored logically, efficiently, and doesn't just collapse into a total mess.
So why is having this blueprint so important? I mean, really, why go through all the trouble? Well, let's take a peek at what happens when you don't have a plan.
Just picture it. You've got customer names in one dusty ledger, sales receipts stuffed in a filing cabinet over there, and product lists on some random clipboard. Trying to figure out which customer bought which product? Oh, that would be an absolute nightmare. That, my friends, is data chaos, and it's precisely what a good database is designed to prevent.
And this is where the pros come in. Before anyone writes a single line of code for the database, the designers map everything out with an entity relationship model. It's the one thing that separates a powerful, reliable system from what's basically a digital junk drawer.
So what is it really?
An ER model just gives you a bird's-eye view, a visual map of your database. It shows you what you're storing and, crucially, how all those pieces are supposed to connect to each other. It's the blueprint we're going to learn how to read right now.
Okay, so every blueprint has a legend, right? Symbols for walls, doors, windows, and ERD's no different. It's got its own set of symbols. Let's learn the core ones.
First up, we've got entities. The easiest way to think about these is as the main rooms in our building plan. They're the nouns of our database, the big important things we need to track, like an employee, a product, or a customer.
And on our blueprint, you will always see an entity shown as a simple rectangle. So if you see a rectangle, you know you're looking at one of the major parts of the database. Simple as that. Now, a room isn't just an empty box, right? It has features. It's got a color, dimensions, maybe some fancy flooring. In the database world, we call these features attributes. They're the specific details that describe an entity, like an employee's name or their address. And you'll spot these attributes on an ERD as ovals, and they're always connected to their entity. So, a rectangle with a bunch of ovals attached to it, that's our room, with all of its features listed out. Okay, last of the big three. What good are rooms if you don't have hallways or doors to connect them? That's exactly what relationships do. They're the verbs of our database. They show how entities interact. For example, an employee works on a project. See? It's the connection. You'll see relationships on the diagram as a diamond shape, linking two or more of our rooms together. And there you have it. Rectangles for the things, ovals for their details, and diamonds for how they connect. That's the basic language of our blueprint.
All right, basics down. But let's be real. Real-world data is way more complicated than that. A good blueprint has to be able to handle all the tricky, finer details.
I mean, think about it. An address isn't just one thing, is it? It's got a street, a city, a state, a zip code. So how does our simple little blueprint handle something like that?
Well, this is how. It uses something called a composite attribute. See how the main address oval actually branches out into smaller ovals for the street, city, and state? It's a really clever way to keep related pieces of info grouped together under one main idea. And ERDs have other tricks up their sleeve too. For a simple bit of data like age, a single oval is perfect. But what about phone numbers? A person could have a work phone, a cell phone, they could have multiple. That's where this multi-valued attribute comes in, and you can spot it because it has a double oval. And sometimes an entity just can't exist all on its own. Think about a dependent, like an employee's child. That dependent is only defined by their relationship to a specific employee. We call this a weak entity, and it's shown with a double rectangle. It's kind of like a closet in a bedroom. It doesn't really make sense without the bedroom it's attached to.
Okay, so we've read the blueprint, we understand the symbols, even the more advanced ones. Now for the most satisfying part, turning that plan into an actual working building. And this right here, this is the big reveal. On the left, you've got our conceptual ERD blueprint. On the right, that's what it becomes, a relational schema. Now, that's just a fancy name for the actual set of tables that make up our database. See how each rectangle from our blueprint becomes its own table? And the ovals, the attributes, become the columns in that table? Pretty cool, right?
And this isn't just some abstract idea. A developer literally looks at that employee rectangle on the ERD and writes a specific command like create table employee. The blueprint directly tells them what code to write. It's how the visual design gets turned into a solid digital foundation.
So, the database is built, the structure is there. But how do we actually use it? Like, how do we put data in and get information out? Well, you need the right set of tools.
To talk to our shiny new database, we use a special language called SQL. Now, SQL is broken into different parts for different jobs. The two big ones you'll always hear about are DDL, which stands for Data Definition Language. That's for building the structure. Remember that create table command? That's DDL. And then you have DML, the Data Manipulation Language. That's for working with the data inside the structure.
Let's go back to our building analogy one last time, because it's perfect here. Think of DDL as the construction crew. They use commands like create table to actually build the rooms and walls of the house. DML, on the other hand, is the moving crew. They use commands like insert to put furniture into the rooms and select to go look at what's already there. One builds the house, the other furnishes it.
So there you have it. From a chaotic pile of paperwork to a perfectly structured, organized database, the whole journey starts with that blueprint. It's all about planning before you build. So, thinking about your own world, your contacts, your music collection, your work projects, what kind of blueprint would you draw first?